Hi, my name is Hemanth Kumar MJ. Currently, I am studying as a computer science engineering in UBDT College of Engineering, Davangere. Today, I am going to explain you about the attendance management system using face recognition. So, as we know, the attendance system is very important through our college life, our school life. So, I am going to explain the this attendance management system using our face recognition. So first we are going to learn about the introduction. So as we know, students attendance are taken manually by using the attendance sheet given by the faculty. So it is a time consuming process, right? Around 10 to 15 minutes has been gone through the attendance management attendance taking. Moreover, it is very difficult to verify one by one student in a large classroom environment. There is a 150 200 students. It is very difficult to maintain and verify them one by one. So uh, for this type of misconception or a false attendance, so we are going to learn about the face recognition. Initially, it is a gradually evolving process in a biometric solution, since it requires virtually zero effort. So there is no effort from the user. He has to come in front of the camera, and the face has been identified and verified. Then the other biometrics options like fingerprint, you have to press your thumb finger. There is a there is a effort in that biometric. So it requires a virtually zero effort, and it is accurate and allow eye enrollments and verification rates. It has a eye verification rates, and it's also accurate. So in face recognition, attendance presence are monitored in real time, and there is a the attendance which the student is present is monitored in the real time. So what exactly is a face recognition? So a face recognition is a computer applications for automatically identifying and verifying a person from a digital image or a video frame. So in order to verify your face, you have to come in front of a camera or a video frame which has been recorded. So this facial recognition is it's a computer applications. It automatically identify your face and verify it from our database, from the digital image or a video frame that is currently running. So one of the ways to do this by comparing the selected facial features from an image and the facial image which has been recorded, and it is compared to the facial database, that is the face which is stored in our database, and it compared two images, and it will give the final output. So we learn about a face recognition system framework. We will discuss these frameworks one by one in the next slides. First, we will learn what are the its framework. So first, there is a face image acquisition, and then a face detection is going to take place. After obtaining the face, the image processing, the face has been processing and image is processed, and the features from the image has been extracted. These features is matched with our database, and then the conclusion or identification will take place. So implementation of how we implement the face recognition. So it almost occurs in the three stages. As we discussed in the above slides, there is a face acquisition, and the first stages is the face image acquisition, and then the image processing will take place, and then the identification will take. We will going to learn this three stages in one by one. So first, image acquisition. Facial scan technology can acquire face from almost static camera or a video system that generates image or is of sufficient quality. So in order to make your face, you need a face to recognize. So this technology can acquire the faces from almost any static camera. There is a camera which can acquire your images, and a video that is currently running is recording your faces, and then it generates an image of sufficient quality which can be compared with our database, and then the output has been generated. So the captured image is converted into grayscale image. So when the image is being captured from a video system or a camera, this image has been is converted into a grayscale or resized to element was so to eliminate other objects in the images, the image has been cropped to a grayscale. So this is the face acquisition. After the face acquisition, there is the image processing. What is image processing? The face has been acquired or a face has been captured. These images are cropped and colored almost. The image which has been captured is a colored image, has been cropped, and normally this colored image is converted into a black and white in order to facilitate initial comparisons based on the grayscale characteristics. So first, the presence of faces. or face in a scene must be detected. In order to image processing, for the image processing, the faces or a face with which the through which the processing has been takes place is been detected. Once the face is detected, it must be localized, and normalization process may be required to bring the dimensions of the live facial samples in alignment with one of the template. To compare this, the image has been cropped and it is converted into a grayscale, and then there must be a localized and normalization process will take place. After the image processing, we are going to extract the facial features of that image. So all facial system attempts to match visible facial features in a way that the people. So as we so one person is identifying the another person through their facial features to their appearance. So likewise, this facial technology has been working. So facial scan system attempt to match the visible facial feature. So the image which is being cropped, it has some facial features. So these facial features has been um, matched with our database facial features and then identify one of the is present or not. The features most often utilized in the facial scan system. These features has been utilized in the facial scan system under process of extracting facial. So the facial features are almost like the eyes, our nose, our mouth, etc. for human being images. So then the facial recognition algorithm, we are using two algorithms, that is R cascade algorithm and LBPH algorithm. So first we are going to learn about the R cascade algorithm. R cascade algorithm, which is productively used for object detection. That is, in a video frame we are going to detect some object, that is our face is an object. So this algorithm which helps us to detect the object in the video frame. So this algorithm is based on the machine learning approach in which lots of images are used. The algorithm is based on the machine learning approach. There is lot of images has been used, that is a positive images and also a negative images has been used to build this algorithm or to train the classifier. This involves the four stages that include. So uh, there are four stages. The first, learn what is positive images. These are the types of images that we want our classifier to identify. The type of that is our face is a positive image. So these are the type of images, that is images that we want our classifier. I want to identify the face. That is that our image is a our face is an image, that is a positive image. So and negative, what is negative image? There are the images that contain something else, that doesn't contain the objects we want to detect. It contains something else, our background is a negative image. So the R cascade algorithm, which uses lots of images, the positive images has been also used and the negative images has also been used to build this algorithm. So this involves our four stages. This R cascade algorithm has four stages initially. We are going to discuss these four stages. R there are The first one is R feature classification. As we know that the each image is a group of pixels, so it is the first stage, and R feature calculation is the first phase. It is nothing but the calculation that happens on adjacent regions at a certain location. It will take place The calculation has been take place at the adjacent regions, that is 1 pixel or 2 pixels, and it has three features in which the calculation is been takes place, that is a two rectangle features, three rectangle features, and four rectangle features. Then after the R feature calculation, we are moving into the integral image creation. So integral image creation is nothing but a subgroup of, we can say able to say subgroup of a R features. So in R feature, we are going to calculate the calculation. The calculation is been takes place through adjacent regions. But in this integral images, essentially by the calculation of R features. So this takes place through this R features instead of computing. As I say, it is takes place at every pixel. So it instead creates a rectangle band that creates an array references for each of those rectangles. So after this integral image creations, we are going to adapt boost usage. Adapt boost usage is nothing but essentially chooses the best features and train the object. We are going to train this object, that is the image has been trained to detect the image, that is the object has been detected. So after this, a cascading classifier implementation. It is a method for combining increasingly more complex classifier like AdaBurst in the cascade, which allows the negative, that is a non-face, to be quickly discarded. So as we discussed about the negative images, that in this cascading classifier, the negative images and that is the negative input has been discarded. Only the what we want, the face is only taken, and which reduces the computation and time and makes the process more efficient. Which due to cascading classifier implementation, the it is a more efficient and decreases the time in other process and other discarding. Then we are moving towards the LBPH algorithm. LBPH algorithm is nothing but a local binary pattern. Is simply but efficient texture operator. It is combined with the histogram of gradients to recognize faces in image. In images, there is other objects like a cardboard. There is a cup. In these objects, the image has been identified. So this LBPH algorithm is used to identify these faces, identify the faces in the image. It uses the four parameter like radius, neighbors, what are the neighbors, and the grid X and the grid Y where the image has been present. So these are the how this is how the LBPH algorithm is works. So this is the output. Here, as you see, my name has been displayed in the window screen and rectangle has been displayed. So we will discuss about how this program works in others the next future slide. So identifying the image has been taking place here. So next, our image has been see the name the Hemanth, the attendance has been taken place Hemanth, and the date has been identified where when the I am ever present and the time when I enter the class. So after this is the HTML form. There is a web front end details in which our colleague's name has been identified and the date when they are arrived to the class and the time when they are arrived at the time. So this is the friend. This can be accessed to all the lectures which can be displayed. So what are the application of face recognition? The primary application being used in classrooms to take attendance. As we discussed, this is the attendance management system using face recognition. It is the main applications of the face recognition. Decreases the false attendance. As we did in our classroom, right? That we takes the attendance of our friends who doesn't present. This will be decreases the false attendance and enables the record, store, and monitor student. The attendance has been stored, monitored, and recorded. These facilities are available in this facial recognition and history, and we can manage the classroom efficiency. So automatically identifies and confirms a person and records. As we discussed, it requires the virtually zero effort from the user since it identifies automatically and confirms a person and records attendance based on their face detection. So what is the conclusion? Therefore, the purpose of this project is to capture a video of a people and convert it into frames. Link it into to a database to ensure their presence or absence. That is, whether the student is present to a class or absent. This is the main applications. And to mark the presence of a real student to keep the record. Here in this slide, we are keeping these records, right? A month, the date 9/5/2023. I am present in the class and the time when I present in the class is the 1 o'clock. So this is the time and these are the real-time student records that can be visible to other lectures. The automated classroom attendance system helps to increase accuracy and ultimately achieve the highest accuracy of real-time arrival and to satisfy the need of automatic classroom testing. So yeah, now we are going to learn how the code has been written and how it's going to work. So first we need to store the images the members of the classroom. I will show you the photo of that. We have created a data sets in which the images has been present. See this image, the images has been we are storing three images has been stored. So first we are going the face checker detection in Python. We are going to import CV2, the open CV, which is used for video capturing. So and we require a random number to store the images which we are captured. So we're creating an object which is called a cam, and it is a video capture through our webcam. So we are creating an string crop, that empty string, and a cascade. What is cascade classifier? R cascade frontal face. So it's a R cascade designed. It's a R cascade. This is a R cascade which is designed by the OpenCV to detect the frontal face. It works on training the cascades of thousands of negative images with positive images. So this how this works means, we are training the negative images and positive images which is superimposed to each other, and then when we trained, the image has been detected, the face has been detected, the object has been detected from that image. So we are writing one for while loop, that is for a continuous capturing of a frames. So the read function is used to read the camera. So gray, the captured image has been converted into the black and white. The faces cascade dot detect multiscale. The gray, which is an image that is being detected, and a scale, this is the scale factor, and this is the neighbors. So we are taking on five neighbors, approximately five faces has been identified. So these faces has been printed. So we are creating one for loop, that is we are going to create on rectangle face. That is there is a rectangle in our, when the face has been identified, it shows a rectangle in our face. I will show the output next. So this is the image which has been identified, and x comma y is the starting point where the rectangle has been started, and x plus width, y plus height, this is the width in the according to along the x-axis, and height along the y-axis. So this is the RGB color, and this is the thickness, and how much thickness the triangle should be. So these images has been stored in the crop string. The crop string has been stored. So I am show this image, the image has been stored in the other page. The I am show function is used to store the image. That's my image. That is image has been stored in the my image folder. That is my image folder. Wait, what is wait key? This which allow the user to display window for the milliseconds, which opens the window for a unlimited, that is a one or any key, until I press some key, the window doesn't close. So the k has been stored this wait key. So if I press h, it will break, or else if I press yes, it will stored on, as well the images has been stored in our data sets. So this is where our data sets will store. So data set, dataset 0 cropped index dot jpg, the random, which is the generates the random number of numbers to maintain. So I am write function, I will show you the output. For this I am going to activate my project. So sorry, I'm just mistyped the spelling. So the my project has been arrived. So I'm going to run this program, Python, which is the face detection. Currently I am using a webcam, so it doesn't opening. So I am showing you, this is the output. These are the images has been, and here you see the rectangle, right? This is the rectangle has been generated, that is being generated, and this is the faces that is been identified in a webcam. And you see right here, k is equals to or h. This is when I press the h, it will break, and when I press s, the screenshot has been taken. The screenshot has been taken and it is stored in the data set, which is 0 and cropped. There is a name of the index. That is, index is a random number which generates from 1 to thousands. We can store approximately 1,000 numbers, 1,000 images for the training process in a jpg format. So after the training, the image has been written. There is a file name has been written and the cropped image has been written. So after the face has been identified and it is stored in the database, right? We should need to train that images. That is like, yeah, we are importing a list directory, that is a list of directories, and a cv2 for a video cam, and import numpy. So root directory where the variable which stores the data set, that is the data set which that has been yeah, the data sets has been, the images has been present. The image has been present in this data set, and if the array features and the labels are the arrays are empty arrays. So we are opening a for loop, that is a for subfolder in a list directory, that is the root directory. That is the image are present in the data set. This is the root directory. So we are presenting a some path to print, that is a root directory divided by subdirectory. So we are printing this path. So where the image has been present, how many image has been present. So inside the for loop, we are creating one more for loop for the files, that is how many images has been present, the file name, path, where how the from where the path, and the file, which file the image has been present. So the from this the image has been read, and we are resizing these images, that is to a window size 350 to 350, and we are appending the images. So in after this functions, after this for loop, we are coming out of the for loop and we are printing the number of features, that is the length of the features, that's how many images has been present, and the labels how many, like around, I am going to run this program now. Python, I just see now there is a features. These are the features for one images, like 151, 150. This is a feature of one images, and we are printing a labels, that is a zero. In one folder, that is a zero folder, that is a 20 images has been present. In a one folder, there is a approximately 15 images has been present. In a two folder, approximately 115 to 20 in the three folder, there is some images of a person has been. We are training these images to detect that a person when he enters, when he come in front of a camera, right? So after this, we are going to verify the attendance. So for this, we need a date and time through which when a student is appear, when a student attending the class, the time is required. So we are, for this we are printing a date and time, and a cv2 for the face recognition and my api. Now we are creating a variable in which cv2 that face has been identified, through which the face has been recognized, as we discussed above in a algorithm, right? LVPH algorithm. It is a local binary pattern but efficient texture operator. Approximately it has how many radius the image has been. So RECONG, the recognize is a variable which in which the LBPH face recognizer creates. This is the algorithm that is being imported to recognize this variable. This recognition variable that is going to train, that is a dot train, which train the features and the labels. The features of the image has been trained, and the labels and how many images has been trained. And these images are these the trained images are stored in the face model.yml. So this is the face model.yml. It it has the features of images and the labels of the images, how many images is been present, and the features of the features of all the images has been present. So once the image has been trained, we are going to next part called verification part. So we have created a file name called verify.pip, in which the cv2 opencv has been imported, and the date and time for which the when the student is arrived to a class, the time has been, the date and time has been recorded in my API. So recognition is a variable which contain the LBPH algorithm, and we are reading this recognition will the as we have created a face model dot YML, right? This YML dot YML is readed by the recognition, and we are stored the four folders as I showed. We are storing the four folders of different images. So these images has been named, so 0 for Hemant and 1 for Varsha and 2 for Pawan and 3 for Pantesh. These are the four police which has the four different images for four. And cam, this is the we are creating an object through which the video capture can be stored. So cascade or cascade algorithm and discard in the above. Same as we detect in the file. So in this we have there is a